Finally, you can write the expression for YC in going to be in terms of correlation. So finally, YC is equal to J omega CGS plus GM into this correlation term. So you write in terms of the final capacitance. Final expression alone is important. You can remember that, and you can see that in the expression for YC, you have C and CGS coming. So C is going to be the correlation coefficient and CGS is going to be the gate source capacitance. So that is going to determine the noise characteristics of your MOSFET. The final expression after simplifying, you can see this is what is the final expression after simplifying. Wherever, since you know C is a complex number, so wherever you have C, you are going to put modulus of C and you take the magnitude of the correlation coefficient. And alpha is unity for long channel devices. So for whatever long channel approximation you are going to make, you can substitute alpha equal to 1 directly, whereas for short channel circuit the value of C will be there and alpha is not going to be equal to 1. So the correlation admittance is purely imaginary, so that GC is going to be 0. So admittance is going to be 0. So YC will not be exactly equal to CGS. So when the admittance is 0, they say that YC will not be exactly equal to CGS. However, one cannot maximize power and minimize noise figure simultaneously. So if you want to control noise, focus will be on that, and you cannot increase power by minimizing noise. Or if you focus on maximizing power, only the focus should be on increasing your power and you cannot minimize noise simultaneously. So both, if you do one thing, the other will be out of control. That is what is the observation done here. And the different parameters you see here summary. So GC is 0 and BC, RN and GU values are given here for your reference. And you can find the real part of the source admittance. In G, you can find the real part, and finally you can find the noise figure. So the minimum noise figure of MOSFET is given by this expression. And you can see the expression is exact if you write omega t in terms of GM to CTS. So your noise figure depends on frequency omega and the threshold frequency omega t. So if there are no gate current noise, the minimum noise figure will be 0 dB. So the minimum noise figure is 0 dB, means there is no noise at all. That is, the gate noise is completely absent. But it is a theoretical value, and ideally no circuits have this particular value of minimal noise figure. So when you increase the correlation, the noise figure will still improve, but it will reduce your noise. It will not be effective for increasing your noise figure to a greater extent. So one observation is that if you scale the technology, you can improve noise figure. So scaling means you are using more components per area. So that is going to increase the value of noise figure at a given